Linear function can collect orthophotos for belt-shaped areas such as rivers, pipelines, and roads. On the home page of DJI Pilot, click Route, create a route, and select Linear. Different from mapping in oblique, linear is to map the surveying area by planning the center line of the target area and its expanding area. You can click on the map to add points. The center line of the target area will contain all the adding points. By dragging the points, you can adjust the center line. Click plus button to add more center points. You can also generate points by entering their latitude and longitude. Click Delete button to delete the selected center points. Click Clear button to delete all center points. Using the Map Switch button to switch satellite image to topographic map. You can also change the base map source in command settings. You can generate mission areas by importing a KMZ file as well. However, it should be noted that the KMZ file format needs to be polyline instead of polygon. After the task area is set, you can rename it, and the task name will also be used as the file name of the data storage, so the mission data can be found after mission is completed. In Select Camera Interface, select Matrice 30, which has three shooting methods: wide, IR, and wide plus IR. Refers to the wide angle, infrared, and wide angle plus infrared camera. Choose a wide angle camera when the distance from the subject is 100 meters and GSD is 3.56 centimeters pix. Choose an infrared camera when the distance is 100 meters away from the subject, the GSD is 13.19 centimeters per pix, and oblique GSD is 18.65 centimeters per pix. When wide angle and infrared camera are selected, only infrared GSD data will be displayed. When the setup is complete, the mission area will be generated according to the default parameters. Open single route. The center line is the flight route. In flight band menu of this mode, expansion length is the distance extended from the center line and generates an area which is used to cover the target area. Due to the limited camera coverage, expansion length will influence the minimum flight altitude of the route. The function of flight band cutting distance is not implemented under single route. Click Fly Route, and the flight route will be generated according to the default parameters. ASL-ALT menu includes relative to takeoff points, and ASL, it determines the datum for calculating route altitude. The route altitude in relative to takeoff point mode indicates the height relative to the takeoff point when the aircraft is operating. The route altitude in ASL mode refers to the altitude of the aircraft relative to the droid of EGM-96. When performing aerophotogrammetry work, relative to takeoff point mode is generally selected. Target surface to takeoff point appears in relative to takeoff point mode. The height of the target surface to takeoff point is equal to the height of the target surface minus height of the takeoff point. For example, if the aircraft takes off from the roof of a building 10 meters high above the target surface, you need to set the height of the target surface to takeoff point to minus 10 meters. When ASL is selected, the flight route altitude option appears, which is the height of the flight route minus the height of the target surface. We use this height to calculate the GSD value. Takeoff speed is the flight speed of the aircraft when reaching assigned height of the route, but not entering the route. It is not the speed at which the aircraft takes off vertically. It can be set to the maximum to improve the operation efficiency. Speed is the operating speed of the aircraft during the route, and the maximum speed value is related to the GSD and frontal overlap ratio. The boundary optimization menu doesn't work in single route. The photo mode includes time interval shot and distance interval shot. Time interval shot is used to take a continuous series of photographs at each specified time interval. Distance interval shot is used to take a continuous series of photographs at each specified distance interval. It is recommended to select distance interval shot mode when executing mapping mission. Upon completion is the flight action when the aircraft has completed the mission. It includes 4 options: exit task, return to home, land, return to start point, and hover. The default option is return to home. Select return to home. The aircraft will return to the home point after completing the mission. If you choose to exit task, the aircraft will hover at the last waypoint after completing the operation, waiting for your next command. Return to home is recommended when takeoff and landing are at the same location. You can choose exit task mode if you follow the aircraft. In advanced settings, frontal overlap ratio is the overlap ratio of photos on a single route, and its default value is 80%, which is suitable for most scenarios when shooting with a wide-angle camera. If the mission area is flat, the overlap ratio can be appropriately reduced, such as setting the side overlap ratio by 60% and frontal overlap ratio by 70% to improve the efficiency. When the single route is turned off, the extension length under flight band mode is the distance expanding from the center line. It is used to monitor the coverage of target area. According to the actual condition of target area, you can expand both sides of the area at the same time, or change them separately. Flight band cutting distance can divide the flight band into smaller parts. The dividing way is related to UVA's communicating distance. A small area operating could reduce the opportunity that the aircraft loses control. Click the flight route. Open Include Centerline. The flight routes will be generated from the centerline. Include Centerline function will make sure the centerline is included in the flight routes. Once the boundary optimization function is on, one flight route will be added from each side of flight band, which means you get more photos of the band edge details. In advanced settings, the default side overlap ratio is 70% and the frontal overlap ratio is 80%, which is suitable for most application scenarios when shooting with a wide-angle camera. If the mission area is flat, the overlap ratio can be appropriately reduced, such as setting the side overlap ratio by 60% and the frontal overlap ratio by 70% to improve efficiency. If the task area fluctuates greatly, it is recommended to increase the overlap ratio. For example, set the side overlap ratio by 90% and the frontal overlap ratio by 90% to ensure the reconstruction effect. After setting the parameters, save the task. Pre-flight check. You need to find an open space to start your flight mission. The ground of takeoff point should be flat and clean. Make sure there is no small pebbles, plastic bags, and other debris. Expand and power the aircraft. Retrieve the task in the DJI Pilot app and click Upload Flight Mission. In Pre-Flight Check menu, check the parameters of the aircraft and the status of the UAV Health Management System and confirm that everything is working properly. Exit the HMS module. Make sure the remote controller is in N mode. The aircraft and the remote controller receive enough power and the positioning information is normal. If the RTK solution is needed, the RTK status should be fixed before starting to work. Make sure the SD card has enough space for this task. If not, it is necessary to replace or format it. RTH altitude and max altitude need to be higher than the flight route altitude. The home point setting is determined by actual situation. If the takeoff and landing position is changed, it is recommended to update the home point. Out of control action is the losing control behavior when the aircraft is not executing the flight mission. You can choose hover, land, and return to home. The default option is return to home. If you turn on max flight distance, you need to make sure the distance between the furthest waypoint and the home point is less than your max flight distance. Select your control stick mode based on the actual situation. The default mode is Mode 2. In scenarios with strong winds or the batteries have large number of cycle counts, it is recommended to increase the power alarm values of customized battery warning. When there are many objects around the takeoff or landing site, the obstacle sensing settings can be adjusted to ensure a smooth takeoff process. Click Next, confirm the route length, estimated operation time, number of waypoints, and photos taken. Confirm whether Save Photo setting correctly, and check out the Reconstruction GSD. If you choose to shoot with wide angle and infrared camera at the same time, the GSD shows the IR camera's value. Check RTK status. Upon completion, actions include exit task, return to home, land, return to start point, and hover. The default option is return to home. Out of control action is the action performed after the aircraft is out of control, including hover, land, return to home, and continue. The default selection is continue. Created folder is where the capture photos are stored. The default file name is the task name, which can be modified. Camera mode includes auto, automatic exposure, and manual exposure. It is recommended to use auto in well-lit scenes, and manual exposure can be used in low-light scenes. When you choose you can adjust the shutter speed to ensure the shooting effect. After checking all flight route parameters, click the Upload Flight Mission button to start the task. During flight execution, pay attention to the aircraft's battery level, image exposure situation, and the remaining space on SD cards. Switch to FPV screen. Observe whether there are any obstacles in front of the aircraft. Also, you can see the next waypoint the drone is flying to as a blue triangle. If one sortie fails to complete the mission, the aircraft will record the location of the interruption, and after the battery is replaced, the aircraft can continue to operate from the point of interruption. After completing the mission, check the status of the aircraft first. Then, transfer the mission data from the aircraft to DJI Terra, and you can generate 2D visible light or infrared orthophotos. Thanks for watching!